In this video, we're talking about factoring the difference of two squares. And the reason we call it the difference of two squares is because we have two perfect squares and we're taking the difference between them. So for example, if we look at this first expression, x squared minus 16, we have two perfect squares, x squared is a perfect square and 16 is a perfect square. And we're taking the difference between them. In other words, we're subtracting one from the other. So in order to take the difference between two squares, we need one positive square, this is positive x squared, and one negative, this is negative 16. As long as we have two perfect squares and we have subtraction in the middle, factoring this expression is going to be really easy. All we do is take the square root of each of our perfect squares, so this is going to be equal to, let's go ahead and draw our parentheses here. The square root of x squared, what do we have to multiply together to get x squared? Well, that's just x and x, so we put those in place. Then what's the square root of 16? Well, that's 4. 4 times 4 is 16. So we put our 4's in place here, and then we just add one and subtract the other. And if we multiply out these binomials, we're going to get x squared minus 16. So we do the same thing here. What do we have to multiply together to get y squared? Or in other words, what's the square root of y squared? That's just y, so we go ahead and put our y's here. Then the square root of 25 is 5, so we put our 5's in place. And then we add one and subtract the other. Now we could do that because y squared was a perfect square and 25 was a perfect square, and we had this difference in between them. We had the subtraction, so we know that we could factor this as the difference of squares using this method. Now before we go on and do the rest of these examples, let's show you really quickly why this works. We'll go ahead and FOIL this back out. So we're going to do x times x gives us x squared. X times a negative 4 gives us a minus 4x. 4 times x gives us a positive 4x. And then positive 4 times a negative 4 is a negative 16, so we get minus 16. So here's the reason that this always works. When you do this, when you have identical binomials except that the sign is different in the middle, one's positive, one's negative, you're always going to get one negative term, which is the same as or the opposite of this positive term, and these two are going to cancel with one another. A negative 4x plus a positive 4x is going to give 0, so we're just going to be left with x squared minus 16, which is what we started with originally. And when you have two perfect squares and you take the difference between them, this will always be the case. You'll always get these two middle terms to cancel with one another, which is why we can factor this way. So let's look at the rest of these. Here we have 100x squared minus 49. Well, 100 is a perfect square multiplied by another perfect square, x squared, and then we have a perfect square in 49. So we'll draw our parentheses here. The square root of 100 is 10, so we can go ahead and write our 10 here. The square root of x squared is x, and because 100 and x squared are multiplied together, we'll multiply the square root together. And then we have the square root of 49, which we know is 7, so we get 7. We add one and subtract the other. We can also do this when both of our squares are just variables and there's no constants involved at all. So the square root of a squared is a, the square root of b squared is b. We'll add one and subtract the other one. And then here we have x squared plus y squared. Here's where we have to be careful. We have two perfect squares. X squared is a perfect square and y squared is a perfect square, but they're added together. We don't have the difference, we have the sum. Neither one of them is negative, so we can't factor this as the difference between two squares. If we look at two more complex examples here, this one is going to be similar to this 100x squared minus 49. What we're going to get when we take the square root of 49 is 7. The square root of m squared is m, and because 49 is multiplied by m squared, we multiply the 7 and the m. And then the square root of a squared is just a, and so we add one and subtract the other. And then here we have negative 36 x to the 6th power times y to the 4th power plus 49a squared. And you might think that this isn't the difference between two squares because we have an addition sign here in the middle. But notice that we also have a negative sign leading out in front here of this 36, which means that we can flip the order of these terms. This is a positive 49a squared and a negative 36x to the 6th y to the 4th. So what we'll do is call this 49a squared. We kept that positive. And we're going to keep this term negative. And so now we have the difference between two perfect squares. So the square root of 49 is 7. The square root of a squared is a. The square root of 36 is 6. The square root of x to the 6th is x cubed, so x cubed, and the square root of y to the fourth is y squared. So we have y squared here and y squared here, and then we just add one and subtract the other. And that's how you factor the difference of two squares.